हाँ जी, कैसे हो सब? So welcome back to our final part of DBMS in one go. And people who are new to this video, make sure you went through our last part of database management system in one go, right? And today's video, last video was kind of basic video, right? Where we just ran you through some of the basics of, let's say, what databases are, why they are different than file systems, right? What are the things that databases offer but file system does not, right? And these things we discussed, which were basic. And today we'll take a step ahead and we'll discuss about Instagram. We'll design Instagram ER diagram. Last video we designed enhanced entity relationship diagram of Uber, but it was pre-designed, right? For that we just referred what are the entities, what are the relations gonna be, and etc, etc. But today we will discuss Instagram. I will list down the entities, the relationship possible, the requirements, and we'll design the relationships, right? The cardinality and all. Then we will proceed to more important thing, which is normalization. And people do ask normalization in interviews because that is one of the most important concept when it comes to database design. Now after that we'll discuss about indexing, hashing, B+Trees, secondary index, primary index, clustering, etc, etc. But before that, this is the index, right? And make sure you like the video, make sure you tweet on the Twitter if you are following our series. And yeah, let's start the video without any further ado. So before designing the Instagram, you can recall your memories of Uber design, right? The ride management system, I think. So in that thing we designed Uber, and today we'll first thing first, and which is to collect the requirements. Now to collect the requirements, you are the interviewee, right? You are giving the interview, and it's your responsibility to list down the requirements, and in your back of the head you should recall how you use Instagram, right? And if they are not calling it Instagram, if they are just saying that let's design photo sharing app, they can also call this, right? I mean, it is a possibility. Now the requirements that you should gather should be from a real world app, and the app you should like recall in your head that how you are open the app, how you proceed in the app, how you use the app, right? And the first requirement is when I will install the Instagram, I will be able to user should be able to create his profile. Now in this profile, different things will come like email, password, profile picture, your gender, etc, etc, right? And with creation update, got it? So user should be able to create, user should be able to update his profile. Now coming to the profile, now I'm talking about the profile can be, profile will have bio, profile picture, profile will have number of followers, number of following, and profile can be private or profile can be public, right? Now the thing is ki if you are gathering the requirements, your requirements could be different than mine, and it's perfectly fine, because see, whenever you are collecting the requirements, it's up to you, and there is no fixed roadmap, or there is nothing written in the book that this is how you should collect the requirements and these many requirements only you have to come up with, right? There is nothing like that. It's up to you completely. So yeah, so after the profile I will interact with the app, and with interaction what I meant is ki I can be able to post the photos. So let me list it properly. User should be able to post, share, like, comment. Now what user can post? User can post a picture, a video, like post, only post. We Instagram call that as a post only, and story, reel. Now okay, user can do this, user can do that, and what else user can do? So yeah, I think these are the only requirements. User can log out, that is fine. Now apart from this, user can follow or search. User can search people, user can search places, and now at this time you can ask the interviewer that hey, I want to include people. Like user can search people, user can search accounts, right? Should I include the places also that user want to search? If he says that yes, you should include, then you can. Otherwise, you after asking, you can skip. Okay. So now there could be more requirements. Obviously, there is no bound, and you can come up with that. But as of now, I think these are the requirements. And entities, now entities could be the physical things which have the existence, or the things which have relationship with someone else, right? So first entity, which is very common and straightforward, is user. Now the another entity I can see is profile, because user has relation with profile, and multiple users could have relation with multiple profiles, right? And there is an entity called post. Now these posts can be generalized, I think, that I will think about it. And then I think another thing is places, right? So yeah, this only, right? Or there could be one more requirement, which is user can search in explore button. You can, like, if you use Instagram, right? So that is it. Then relationships, I think we can include relationship also. So post can be picture, post can be video, post can be story, post can be reel. Now few more requirements could come, like user have made a close friend circle. That is also one of the requirement possible, that you can draw anyways, right? And like close friends, if you know that you will have some green circle around your profile, and people who are in your close friend, and those only will view your story. And another requirement could be user can mute people post and stories. Another requirement could be user can block someone. So endless requirements. So I have listed only the few that are the first impression for the user, the requirements that user will have at the very first step when he installs the app. So yeah, so relationship of user with places is user can search places. Okay, so it is user searches places, and user likes a post, and user has profile, right? User has profile, user has to have one, like it should be one-to-one mapping though. And another thing is post, which is picture, video, story, a reel. Post is posted by user, that could be one of the relation. Now see, I am confused, okay, because user and post have multiple relationship. The first relationship it has is that user can like a post, user can share a post, right? And the multiple actions are associated with post. So what should we do? Okay, so we can draw multiple I've just asked Gemini that we can draw multiple relationship between two entities. And so yeah, post can be liked or I would say interacted. Now the interaction could be comment, like or share by user. Okay, so post is interacted, so post is interacted by user. So this is the relationship I think is interacted, has likes, searches. Now another thing is that profile post. Okay, user can search places, user can search profiles, right? User can search profile, and user likes a post, user has profile, post can be interacted by user. Now this post will be generalized, right? Now coming to the attributes, the attributes for user, let's draw the attributes itself. Okay, now for user the attributes would be the normal attributes, right? And user is a strong entity, so user will have attribute. First of all, name will always be a attribute, DOB, date of birth, will always be a attribute, age again is a derived attribute, and phone number. Now phone number here in our use case, I think also one account is associated with one phone number, and when you create an account you will get a username, as far as I know, right? And username, and then I think username, phone number, age, DOB, and location. Now this location will be a composite attribute like street, then like the multiple things, city, country, and pin code, right? So, and another thing that will be associated with user will be like there is one or more attribute that I can ask interviewer that should I include this or not, is banned, right? If you're doing something suspicious on Instagram, they will ban you, so that is also there. So if they want to, so this is called soft delete, the people who are not aware. So is banned, if I'll make it a 1, which means it is like the user is banned. If it is 0, which means this is a normal user, nothing wrong with this user. And this is a soft delete. Soft delete means a user will still remain in your DB, all the details of the user will remain in DB till that user gets cleared, right? So yeah, that is soft delete. But anyways, it is up to you that you will ask interviewer. You have a post, right? Now the post, will it be a strong entity or a weak entity? So if there is a post, right, and user deletes his account, then I think the post will also get removed, right? So if that is the case, then this post existence is entirely dependent on the user who is posting this post, right? So I think this is a weak entity, and the post can be generalized to, first of all, picture or photo. The second thing will be video, right? And third thing will be reel, right? Reel or story. So I'll represent one of them as story only. Now on story you can post photo, on story you can post video. Now the user have a relation with post, that user can like a post and user can post a post, right? So the first relation will be likes or interact. User will interact with the post, right? So it's not necessary that one user will interact with all the posts, right? So user complete participation will not be there, and it's also not necessary that all the posts are liked, like interacted. There could be a post which is never interacted by anyone, right? So complete participation from both the ends are not possible, and the cardinality will decide later, or we can decide now, or it's up to you. So one user can like multiple posts, so 1 to many. Now one post can be liked by multiple users, so it's a M2N relationship, right? So from left to right, 1 to many, from right to left, 1 to many, so many to many. Now this photo will have attributes like how many likes it has, how many comments it have, how many share it will have, right? Now when I'm designing, this same thing will have these attributes, right? So what can we do? In this case, we can abstract those attributes out to our common class, which is this. So every post will have comments, every post will have likes, and every post will have shares, and every post will be associated with user. And I think we didn't, so here username is also there. Okay, username is here, so this is a primary key, so underline I have to put here. Got it. Now you have one strong entity, you have composite attribute location, you have a key, and you have a weak entity, right? And for the post, I think post id will be the primary key. Got it. Now and every post will have these attributes, like the abstracted attributes which are common to photo, video, story. Now on the story there is something called reply, right? So you can say that number of replies or story is related with message, right? And now I'm in middle of my design and I just realized that there is some construct called message. So that is also a possible ending. It's completely fine. It's not that I have not prepared for this Instagram design. I'm ending it live so that you can understand how to decide things. So another entity will be message or SMS, right? Now user can send message to another user. So one more thing will come out of this, which is a very interesting one, right? And so that is the Cartesian product. So basically user have relation with user, right? One user have relationship with the user. How you will make that, right? So user can post a message to other user, or user can delete. Basically user can do something with message, right? So the relationship is user deals with message, right? Now that message will have an action, like user can have action for that message, right? Like if user sent that message, if user deleted that message, that is there. So that is just that user deals with message, right? You can make this relation generic. Now let's check self relation or self relation in ER diagram, which is called unary relation also. See, this is the relationship, right? We have gone through this. So user and message, user deals with user. Let me draw it nicely. So this is the relationship, right? User deals with message. Now it's not compulsory that user have to send a message to another user. It's not compulsory at all. And it's also not compulsory that every message should be sent by user. It is compulsory, right? So every message, whichever message exists, it should be dealt with some of the user. Either one user could have sent the message, or one user could have deleted the message, whatever. But so this is the relationship from user to message. This is the relationship from message to user. So every message is related with the user, so which is complete participation. And multiple message can be sent by one user? No. Like one user can only send a particular message, like while interaction he can deal with. So multiple message can be sent by user, yes. So many to one this relationship could be. And one user can send multiple message, right? And multiple user can send one message? No, it's not possible. So yeah, that's one of the relationship possible. And you can come up with a better relationship. Like I have come up with unary relationship. Like to abstract that out, I have come with this: user deals with message. I can do this also, like make a message complete another entity, and every message will have user ID associated with it. And there it could have an action also, like the action is delete, etc, etc. So I think this one makes more sense. So yeah, you can draw this here instead of this relationship. You can use this relationship here. I don't have any space. I think let's try. So let's make a message a entity only. Message attributes you can come up with, like a message, every message is sent by one user, so user id itself can have primary key of message, text it can have, the action it can have, right, the date it can have. Now date is a composite attribute of month, you can say day, month, year. Now the relationship could be user. Now the relationship could be delete, send, so multiple actions user can do. So user deals with this message in a particular way, and I have made that action here. Here that action is there. So a message, if a user is deleted from the Instagram, would it get deleted from the message, would deleted from another user? Let's say user 1 sends a message to user 2 and user 1 deletes his account. Will that message that is being sent to user 2 will get deleted from his profile? No. So that's why message is also a strong entity. It has existence without any without the existence of user, right? So you can come up with the attributes, right? Okay, post. Now you have profile also, right? And you have places also. So post, we have interacted, user interacts with the post, and we have different attributes of post. Now you can come up with post attribute, like here also you can make it photo id, you can give it a separate attribute photo id, though we have a post id, a unique identifier or a primary key, but it's up to you. Video id also you can give, right? And another attributes like video has captions, right? And captions have limit, like the photo caption could have different limit, and video caption could have different limit. So that attribute is very specific to photo and video, and caption is not their own story. So that's why caption will come here, not at the generic weak entity of post, right? So that is there. Now the profile will come. So profile is a weak entity, right? Because if user deletes his account, it has complete dependence on user, the profile should not exist. And the profile will have visibility, like if it is a public profile or a like a private profile, every profile will associate it with one user id, right? You can associate user id here and make sure that you don't need any profile id, right? To uniquely identify the profile. So this user id will become your primary key, and every profile will have number of followers, every profile will have number of following, every profile will have number of posts, last active, whatever attributes you can come up with. And user has profile. So every profile should have existed with some, every profile should be mapped with at least one user, and exactly to one user actually. So that is a complete participation. And one user can have multiple profiles. Ideally, yes, in physical world I can make multiple accounts, but the thing is every user would need a separate phone number and separate username will be created. From Instagram POV, that is not a same user. So that's why every unique user will have unique profile. And one profile can have multiple users? No. Multiple profiles can have one user? No. So it's one-to-one mapping only. One-to-one cardinality is there, right? So we have user, we have post, we have message, we have profile, and yeah, that's it, right? So that's how, like, you will go and collect entities, right? We have collected entities, we have collected relationships, we have drawn some relationships, right? Some relationship I could miss, and that you can draw, but you get an idea, I think, that how I'm drawing in entities, and then we are drawing attributes, and we are deciding the attribute if it is a composite, multi-valued, or a derived attribute. Then we are drawing the relationships and deciding the cardinality and so on, right? I think you got the idea. So let's move. Now the next concept is normalization, and it is so it is the concept which is the most important one, right? So the thing is ki whenever you are designing a database, most of the time you will not pay attention at all to redundancy, consistency, these things. So what happens is, I have already told you that ER diagrams are non-specific. They are not specific to SQL, they are not specific to NoSQL. Okay, they don't know about these databases. They just represent what are the relationship exists between number of entities, right? So when we draw ER diagram, it's completely fine that we can go and draw entities and relationships and etc etc. But when we go and take that ER diagram and convert that to database schema and try to design a database schema, so then it becomes an headache that most of the time what you will do is that you will design some database and you wouldn't even notice that you made some redundant persistence of data and you are not able to handle the consistency, right? How you will understand that and how to conquer that problem, we'll discuss that. How to solve that problem, we'll discuss that. So yeah, let's start. So normalization, when we design databases, there are some issues that might come out of all. Few are data redundancy, data consistency, and we have already discussed about these concepts in our last video. Normalization is the solution, and normalization is a procedure of making your DBs more effective and less error prone. So there are some anomalies. So first anomaly is the insertion anomaly. So if required fields missing and data cannot be inserted. So there is some insertion anomaly. Let's say that you have a student table need name, ID. Let's suppose first it needs ID. Okay, ID, name, address, etc etc, or marks. So insertion anomaly tells us that if you have not used your brain while designing your DB, let's suppose a student is a new student and it doesn't have any marks, then the constraint on marks is that it should not null, then your student would not able to insert in this. You will not be able to insert the record in this table, right? So that is insertion anomaly. A lot of possibilities are there that where insertion anomaly can occur, right? Let's say one is primary key or name. You made a name primary key, and when you are inserting a student with same name, you will not be able to insert. So in that case, are you sure that you made the correct column as primary key? That is one of the thing. Deletion anomaly, if one record deletion may delete other dependents, right? So the thing is ki you have multiple tables in database and you're deleting one record and it is causing some more deletion in another tables. That could also be an anomaly. And updation anomaly is when updation cause inconsistency in data or data duplication. This we discussed that you have two tables, right? You have one student in table 1 with some info and that only student with same ID in another table with other information. Let's suppose one table has class information, another table has student information itself. And whenever you are deleting the student, it's not deleting the class of the student and other info in the database. That's what we do in a weak entity and strong entity. If there is a weak entity and you are deleting the strong entity ka record, then it should delete the one-to-one mapped weak entity ka record also, or all the mapped one records to the strong entity from weak entity you should delete, right? So these are some of the things that normalization will solve. So in normalization, we have to put closely related information together, and to find the closeness, we must know the functional dependence and keys. So these two keywords are most important, functional dependence and keys. And most of the MCQ will have these attributes in your question or in answer, that this has functional dependence on that, this has that, and the keys that which are functional dependent on this are these. Okay, so what are the keys? So these are not primary key, these are not foreign key. Keys are just unique identifiers. So let's suppose in a student table, the key will be student ID or student roll number, which can uniquely identify a student. So student ID can determine name, student ka name, student ki age, stage, student ka grade. So this information tells us that the relation, that is how a piece of data can determine the information. So functional dependence and keys are strongly related. So my key is, let's suppose, student ID. Okay, and it can determine how many attributes it can determine: name, age, or grade in the table. And then I will call that my table columns which are name, age, grade are functional dependent on student ID. Student ID is my key, who is defining the attributes, who can uniquely identify the attributes. So what are the advantages of normalization? This is most important, that elimination of data redundancy. If duplicate data exists in multiple tables, you will normalize the tables and you will abstract the data out. Or the other way around, like if all the data is packed at one place, right? There could be anomalies while insertion, deletion, etc. I'll come to that when we'll design like a very poor designed Instagram to a normalized form Instagram. We'll design that. So elimination of data redundancy, ensuring data consistency. So this is one of the advantage, that if you are deleting something or updating something in one table, if it is strongly related with some information, it will delete or update that information in another table also. Ideally, at the very first place, it should not be scattered around the tables, right? So that in one transaction, you could you have to update or delete like one record first and then go in another table, update or delete that record again. It's a poor practice. Now the third thing is simplification of data management. Again, you don't have to go at multiple places and do stuff. So simplifying the management itself is a great point. And avoid update anomalies. That is again data redundancy. Now the disadvantages are increased performance overhead, additional join operations. So what happens is, in our org also, we kind of avoid join operations as much as we can. So see, you made one table and you put all the information of Instagram in one table. Then you came to know that it can have update anomaly or insertion anomaly itself. Because see, if let's suppose post column is also here and post is null always for new user, and there could be a constraint that post can never be null, let's say, or any other attribute, and which could be null for this table, because let's say for this table, for all the attributes are available, but one of the attributes is not available, because that attribute will come later on when user will go into his journey, will use the app and will do stuff, and then those other tables will get affected. But the thing is, we have already put all the data in one table. So what will happen in that case is that you will not be able to insert, first of all, will not be able to insert. So insertion anomaly or updation anomaly. And the thing is, if you divide this table into multiple tables, so that the more important data or close related data is in one table, another close related data is in another table. So in that case, it will increase the performance overhead or additional join operation. So whenever you want to extract the information, all the information, you have to join. Now what are the joins we'll discuss, but you have to join or take intersection or union, right? There is something called intersection in maths or set theory, which is to take common things. Like we have student ID here, we have student ID here. So we can use ID here to determine some more attributes here, right? We'll come to that, don't worry. It is complex. Okay, so some jargon before we start normalization is that we have primary key, we have composite key, we have super key. All these keys are very important, could be asked in anything, any test or MCQ. Primary key, any key which can completely identify the records, whichever the records are present in the table. Pick any key. If that key is able to identify uniquely all the attributes, then it's a primary key. Composite key is it's also a primary key, but the thing is, composite key is a kind of different key in sense that it has a combination, right? So an attribute or a set of attributes that can uniquely identify a tuple. So if you can say in student table, name could be a primary key. No, name could not be a primary key. But what I think is name plus roll number can be a primary key or a composite key. Now there are two attributes. I can call this key as a composite key because a combination of attributes can determine other attributes, right? Uniquely. Super key, an attribute that might have more attributes required to uniquely identify a tuple. It might contain extra attributes which are not necessarily to uniquely identify. So basically what they are saying is, let's suppose name and roll number are the must to have attributes which will be able to uniquely identify other records, like other attributes in my table. But let's suppose one person comes and he adds name, roll number and address or date of birth. Though this combination both are sufficient to uniquely identify other attributes, but the thing is, even if you will remove the DOB, this key is also enough. So this extra information is there. So that's why this is a super key, like the superset, this is a composite key, and maybe student ID is the primary key, right? So which is a non-prime attribute. So also prime attribute, non-prime attribute. Non-prime attribute is any attribute that is not a part of candidate key. So here this is the candidate key, right? Not a composite key, sorry, candidate key. So any attribute which is not a part of key, your candidate key, like here you have name, roll number, and let's suppose address, that is a non-prime attribute, right? Which is not a part of key. Prime attribute is that is a part of the candidate key. Now the functional dependence or FD is if any attribute A determine attribute B, then we say attribute B can be determined by A. This is the functional dependency of A. Like this A could be student roll number, and this B could be name, this B could be date of birth, this B could be address. So all these are non-prime attributes because these name, DOB, address are not part of any key, and this roll number itself is a primary key. Now this prime attribute roll number can identify name, DOB, address of any particular record. That's why these name, DOB, address, which is our B itself, is functionally dependent on A. Okay, these all are non-prime attribute. This is a prime attribute. So the terms are functional dependence, prime attributes, non-prime attributes. These three things are most important. After, super key, candidate key, that is for one time you can skip them, but these three things you can't skip. Okay, now the third thing is that there is something called transitive dependency, multi-value dependency, join dependency. So these dependency also you should be aware of. Why? Because see, if B could be functional dependent on A, and C or B can identify C, so A can identify B and B can identify C, so A can also identify C. This is the law or transitive dependency. Just bear in your mind that if this occurs, like roll number can define name and name can define DOB, then roll number can also define DOB, kind of this thing, right? Multi-value dependency, it occurs when an attribute determines a set of values. It occurs when an attribute determines a set of values. We'll come to that when we'll take an example. Join dependency, if table has a join dependency, then it means that table can be decomposed into smaller tables, and joining them back will make the original table back. See, same thing I was explaining, that book, author and publisher. Okay, let's suppose we have information of book, we have information of author, we have information of publisher, right? So what can I do is we have a strong, all the information at one place. What I can do, I can check that if to retrieve any information, if table has join dependency, then it means table can be decomposed into smaller tables, and joining them back will make the original table back. So what it is saying, that a book can have relationship with author, a author will have relationship with publisher. So it's like A, B, B, C, right? And whenever we join, so there are a couple of joins, inner join, outer join, we'll see that those joins in action from our SQL example itself on LeetCode. Don't worry, I'll not give you any theory, we'll solve some questions. And what they are saying is, if you have decomposed one table ABC into ABC, and you can convert that table back, then this table has join dependency. This is called join dependency, and this is called transitive dependency. So this is kind of transitive dependency ka acha version. So how many normalization forms are there? So we have first normal form, we have second normal form, third, and BCNF. You can check the full form of BCNF, 4NF, 5NF. Okay. So first normal form is each attribute in your table. What I call attribute is like, this is your student table. These are the columns, column. So these are the attributes itself: roll number, name, DOB, address, and these are the tuples. This tuple can be roll number, can be 121, name could be Rahul, DOB can be whatever, and address could be, let's suppose, Delhi, whatever. So this is a tuple or record. These are the attributes, columns. Okay. So first NF, first normal form, each attribute must be a single valued. The single valued attribute. Like the phone number. It could be a multi-valued attribute in some scenarios. In Uber, it can't be. In Instagram design, it can't be, because one user will have only one phone number. It can't have multiple phone numbers associated, that we assumed. But if a user or any entity has a phone number, and that entity can have multiple phone numbers value, like it can have mobile number, it can have your landline or whatever. So these phone numbers can have multiple attributes. So then if that table has phone number and phone number can have multiple values, what will happen? See, let's suppose student has phone number here as an attribute. So student will come here like 121 roll number, Rahul, DOB is whatever, phone number P1. Now the same information will get replicated. This phone number is P2. Now my requirement comes. What is the requirement is that Rahul has wrong date of birth. Now they will tell that update the date of birth of Rahul in your table, because he wrote his date of birth wrong. So what will happen is that you have to, because of phone number having two values in the same table, you have to modify two values. You have to first update first record, then second record, and it's an hassle. Okay, just keep in mind that if for one updation you have to do multiple things in one table, then it's a poor design. So one NF is each attribute, each column of your table has single valued attribute. Now the second normal form is must. So first requirement is your table is first normal form. Fine, well and good. All the non-prime attributes, non-prime, all the attributes which are not a part of candidate key, should be functionally dependent on the primary key. What does it mean is that whatever your primary key is in your table should be able to uniquely identify all the attributes in your table. That's it. We'll come to that. We'll come to the example. Don't worry. 3NF must be 1NF, 2NF with no transitive dependency. What does transitive dependency mean is that one attribute of your table can identify another attribute, and the same attribute can identify another attribute. Then this could be a transitive dependency. So in your table, there should be no transitive dependency. What is BCNF? So BCNF must be 3NF, and every determinant left side of functional dependency like this A, B is a super key. Okay, must be a 3NF, and every determinant of left side of FD is a super key. So basically this A should be a super key. If B should be a super key, then this is a BCNF form. 4NF must be BCNF, and there should be no multi-valued dependencies. See, multi-valued dependency. Okay, we'll come to that. Multi-value dependency is just that, like if I have primary key A is also determining some set of attributes B, right? And should be no multi-value dependency, and multi-value dependency is here when an attribute determines a set of values, not all of the values, a set of values. We'll come to that, don't worry. 5NF must be a 4NF with no any joint dependency, right? Your table should be crystal and clear, right? There should be no decomposition more possible, right? It should be not like a book author publisher can be divided in book publisher, author publisher something, and you can join them back to make the table. It should not be there. So these are all the 5 normal forms, and according to me, up to 3NF, if you are designing your DB, it's well and good, right? You should not, you don't have to force yourself to go to 5NF. There are disadvantages of going up to 5NF. Okay, designing Instagram DB and normalizing. So first of all requirements are user should be able to create his profile, user should be able to follow the people, user should be able to like, comment and share the post, user should be able to post photo and video. So these are the 4 basic requirements, right? So what can I do is I can okay, we are talking about the normalization. So for normalization, we are only talking about the tables that your DB can have. Okay, so the tables, we're not talking about ER diagrams, we are only talking about the DB schema design now. So what can I do is, in my table itself, I can make all the columns in one table itself, which is post ID, username, photo, video, follower ID, follower name, comment ID, comment text, like ID, liker name, share ID, share user ID. All these columns are present in one table itself. This is the worst poor design that we'll start with. Now we can store all these attributes in one table. Okay, now we will list down the cons. So we have cons, redundancy of the data. What is the redundancy? Username, photo, comment. Redundancy is if three users like a picture. See, you have username, you have liker ID, right? So one user can have multiple likes on his photo. Okay, so this photo can have multiple liker ID. So in the table, what will happen? Let's suppose a photo, because all the columns are in same table, one photo have, let's suppose, 10,000 likes. So here is a photo ID, here is a liker ID. So this photo ID is 10,000 times. Liker ID could be 1, 2, 3, because all the people are different with different user ID, which is like liker ID. So just for one photo, 10,000 records can come. So this is the first thing. Redundancy is there, difficult to manage. Obviously, insertion, deletion, update anomalies are there. Why? Because if 10,000 people liked this photo, due to some controversy, let's suppose people started removing their likes. What will happen? For one post, I have to go to all the records. I have to delete the records one by one. That's what insertion, deletion anomaly could occur. And another thing is multi-valued attributes. Multi-valued attributes, right? So even if I don't make multiple rows for a normal ID photo, even you can see a photo. Because of this, you can see the there could be multiple photos for a one user. User ID is one, post ID is one, right? User can like multiple photos. So 102, 103, it will be like post ID is one, user ID one. First post he likes is 102, second post like 103, and this post likes ID will be also be different. So multiple values for similar, unique things is possible. So 1NF. First normal form, remove repeating groups and ensure all attributes are single valued or atomic. See, this is our first normal form. So now what I'll do is I'll make only the single valued attributes I'll persist. So post ID, user ID, photo, like ID. That's it. So now my attributes are single valued. I'm only talking about first normal form. Don't ask that it still have multiple values. Right. The thing is, what you have done is you have removed the repeating groups and you have just made all attributes as single valued or atomic attribute, right? So you have done just this, that these attributes you have just made them to appear at different rows. Now doing this will have still some cons like updation, anomaly, insertion, everything will have. But first normal form just tells that if you have multiple values possible, just make sure they are single valued, and I can make them single valued by moving them to new rows. Now two normal form is every non-prime attribute must be functionally dependent on the primary key or candidate key. Example, same follower of different users doesn't depend on the user ID if follower ID is not a primary key. Okay, what happens is so it is saying that every non-prime attribute, so this like ID or a photo, right? So my primary attribute here is post ID plus user ID. Let's suppose this is my candidate key. So post ID and user ID are not able to determine the post and like ID. See, post ID and user ID is 1, 1. This is also 1, 1. Ideally, this 1, 1, the combination of post ID and user ID should uniquely identify the other attributes. But this post, which is posted by this user, can have multiple posts liked, First one is this, second one is this. So they are not able to uniquely identify. What does uniquely identify mean is that if roll number is there in your student table, it should have only one name, it should have only one DOB, it should have only one address. One student should have one roll number, which is our primary key here. Similarly, it is our candidate key here or primary key. We should be able to identify only one row of your table, but it is able to identify 2 rows. So that's why second normal form is not there. So what we'll do is divide the table to remove partial dependency. Okay. So in some use cases, user ID plus post ID can be treated as composite key, but username only depends on user ID. See, if username is here, now this username is only dependent on the user ID. This photo is only dependent on the post ID plus user ID. right? So you can see some attributes are dependent on candidate key, some attributes are dependent on a set of attributes in the candidate key. So that's why you have to divide the table. So similarly video depends on user id plus video id. Therefore tables जो हम divide करेंगे will be like this: user id, username. Now other attributes could be name, dob, address, whatever. Now this table, again, all the attributes are functionally dependent on the candidate key. Yes, let's go to the second table. All the attributes are dependent on candidate key. Now the candidate key here is post id, user id. Photo and video, post id, user id. Post id is id which is given when post is made, from which user is made, the user id is there. So these two attributes which is a part of candidate key can uniquely identify every record. Yes. Similarly follower table, similarly comment table, similarly like table, similarly share table. Now this is the power of your normalization. Earlier we have put, although I have not mentioned all the attributes here, okay, all the attributes, because it's not possible for me to mention all the attributes, but from the ER diagram you can understand that if your ER diagram is there, you have attributes for all the ER diagrams, and if you have put all the attributes in your one table, now you have come to database schema design. You have put all the attributes in one table and you are not able to think ki if my database schema is correct or not. Then you should go check one normal form, check two second normal form, divide your tables so that your second normal form can be achieved. Now what does third normal form tell us? That there should be no transitive dependency, right? There is not any transitive dependency in any table. There is no transitive dependency, not here, not here. You can check. There is no, see, this is a candidate key. So this is a can determine by, A can determine B. So this photo can be B, video can be B. Is there any attribute where photo only can determine that? No, nothing, right? Yeah. So the another is BCNF, 4NF, 5NF. So 3NF is no known prime attribute must depend on known prime attribute. There is no transitive dependency here. So what I am saying is this is both 2NF and 3NF now, because 3NF says that no known prime attribute should depend on known prime attribute, right? See, 3NF, no transitive dependency. There is no transitive dependency. It is a 3NF. 4NF, let's go to BCNF. Must be a 3NF, and every determinant of FD is a super key, right? Though every key is a super key. So BCNF is there. 4NF must be BCNF, and there should be no multi-valued dependencies. Multi-valued dependencies, right? There is no multi-valued dependency. You can check that. And 5NF must be 4NF with no joint dependency. There is no joint dependency. You can't divide this table further, so that though, let's suppose this post table can be divided further. Post ID, only post ID can determine photo, and only user ID can also determine photo, let's say, right? You can divide the table, let's say. Are you able to combine that table both back and make this table? If yes, then it's not 5NF. But again, going till 5NF doesn't make sense, because if you will go to 5NF, your joins will increase, and in SQL it's not a good choice to increase your joins. What are joins? I'll tell you. Okay, now let's discuss SQL, right? And joins and everything I'll explain you on the way, right? Don't worry, you don't have to understand the theory. We'll just go and solve some questions and you'll understand what joins are in SQL, right? So you can just go to LeetCode and they have SQL 50 plan. You don't have to solve all the questions, but we'll go through one of them, like one by one, and we'll understand the aggregator functions. We'll understand basically the queries, etc., right? So SQL, now the database schema is done, the ER diagrams are done. Now the next thing comes is SQL, structured query language. So structure word is there, which is self-explanatory, that there should be some query language which is deterministic, that these only keys will do this, these words will do this, like select, where, and, or, etc., right? So SQL, people made SQL just because to give us some abstraction on top of the data persistence, so that we don't have to go to the internals of databases and understand how data is being stored and how to retrieve them. We have just a plain natural language query system. which is processed by query processor, and we'll get the data from our database. So SQL commands which can be divided in few categories, which is DDL, DML, DCL, TCL, DQL. So SQL is a data definition language. You can create your table. You can create your table using SQL. Data manipulation language. You can manipulate the data and alter the tables. Sorry, you have created a student table and you want to add one more column name. You can alter the table. You can update the table and add the column name. Data control language. You can select data, right? You can fetch data. Transaction control language, data query language. See, this is the thing. Data definition language, you can create a table, you can drop some columns or drop a table itself. You can alter the table or you can alter a table column. You can truncate the data. Now DML, data manipulation language, is insert, update, delete, call, explain, lock. These are the words that will be used in the queries. Transaction control language, commit, save point, rollback, set transaction, set constraint. This is slightly advanced, right? You can, we'll come to that. DQL, data query language, you can just select and put the filters like where and or to make sure to more filter out the data, right? Then DCL is grant, revoke, basically granting the privileges to some user. Let's say a user is, I don't want one policy guy to show my user's password. I can grant some permissions to a specific view of my table. So that's there. So I have written down some examples. We'll go through the examples and then we'll go to joins, right? And then we'll just solve some questions and then that will be done, right? Indexing, hashing we'll discuss. See, SQL, you don't have to go and do some crash course of 5 hours on SQL, because see, there would come so many things and you will not be able to digest at all. And that's why go through the basics that I'll tell you. We'll solve some question, and in your homework you have to solve some more questions, and that's how you can practice for SQL. You don't have to go through each and every query and spend 5-6 hours in just a course. Don't have to do that. So first is create table. So whenever you're creating a fresh table, so you have to use create. So this is table and this is table name, and then you have to give all the attributes. Like for the person table, you have person ID, the data type is int, the last name, data type is variable character string. So this is the data type specific to SQL. So this varchar means you can give last name up to 255 characters. So if my name is Rahul, RAHUL, you know how many characters so RAHUL 5, right? So my varchar could be under 5, but obviously all of the people doesn't have like the same length of the name, right? So that's why for safe side, let's say 32, 40, 50, whatever the varchar length is, that's there. So first name, address. Okay, so that's how you can create table, and you can use something called default also. So here you can use default as 0. So if someone inserts a person, right? Someone inserts a person from your code into your database and he doesn't give any ID, it will be default by 0. Another thing is auto increment, right? So if you will say auto increment, so whenever you are inserting any person without giving any data, person ID will be auto incremented. So last inserted person ID, let's say 2, now the next will be 3, 4, 5. Okay, drop table, like it can be, drop can be used like this, drop table or a drop column. We'll come to that. So drop table shippers will just delete the table. Truncate table person will delete data from the table. Now alter, we are altering the table. Alter table person can have multiple things, like alter table person, then you can use add column, column name, its data type, or drop column. After this person drop column height, it will delete the column. Rename column, okay, column name, column keyword with column name to new column name. Alter column, now you want to change the columns ka data type, you can do that. Rename table, you can do like this. And now select will obviously check, like let's suppose select you want to from table, you want to fetch first two column 1, column 2, where let's suppose you want to fetch name, you want to fetch DOB from student table where age is more than, let's suppose, 25 years, let's say, right? So this is how you query a table. Then insert, whenever you want to insert a record into a table, so it will be insert into table name, whatever the column we want to insert, values, and all the value of those column. Like column 1 will have value 1, column 2 will have value 2. If there is a column 3 also and you don't give any value for column 3, then column 3 default will be used. Okay, so if let's suppose this is the column 1, this is column 2, and column 3 default is null, default you make it null. So this table schema will have default inserted in itself, right? Now we have joins, right? So this is a table 1, let's suppose student ID, student name, student address. Okay, and this is a table 2 of exam. It has student ID, exam ID, okay, marks. Now I want to find all the students who have marks more than 50. So the information is scattered. In first place I'll get the information about student, in second place I'll get the information of marks. What should I do? There should be something common using which I can extract the data from both the tables. The common thing is student ID is here also, who has some name and address. Student ID is here also, who have given some exam and have some marks. So what I will do, I will extract all the common students on ID. So ID 1 is here, 1 is here. So both of these ID 1 are common. So this is the intersection of both the table. I will extract that out. So these are all the IDs which have record in my student table also, which have record in my exam table also. So I will extract 1, 2, 3. Let's suppose 3 students. It will have name, it will have address, and new table will form with exam ID, marks. Now what I will do after join this new table, after join this new intermediate table, I will query on this new table after join. So this is inner join. Outer join, what does outer join means is, let's suppose we have student 1, 2, 3 in student table 4 with name, with address. And the second table exam, the student 3 have missed the exam, okay, exam ID and marks. Student 4 is not there. But when I take left join of student table with marks, what will happen? I will pick all the common values. So 1, 2, 3 will make a common table. Like this: 1, 2, 3, name, address, exam, marks. Now as I have done left join means include the commons with all the values of left also, with null where other values are not given. What does I mean is that the fourth exam is not, the fourth student haven't given any exam. That's why the entry of fourth is not present in the marks table. But still 4 will come because I have took the left join. So all the values will be present. All the values of left table will still be present here with the name, address. But as there is no value in right table, so it will be null. Okay. Right join ulta. Right join ulta. Right join means take the commons and all the values of the right table, right, and the columns which are not associated, because right table have some values which are not present in first table. Those values will be null in new table. That's what. Okay. And full outer join is to basically a union. Okay. So we'll solve some SQL question. You will understand few of the queries, and for interviews, as you know that this course is only focused on the interviews and placements. So that's why we'll solve some question. We'll not spend so much time on SQL. There is no need. Okay. We'll discuss about these. So the first question is, you have a products table. Okay. You have a products table. And the product table have column product ID. So this is a table. You have product ID. You have product name. And not product name. Fats and recyclable. fats recyclable. So product ID is the primary key. So this is the primary key. Okay. And this is the enum, low fats and recyclable. Enum is basically a constant map. See, let's suppose one of the enum is payment method. Let's suppose payment method is a column, payment method. This is the enum. The data type is enum, not int, not string, varchar, it's enum. Enum means it will have specific deterministic values. Let's suppose UPI, credit card, debit card, or cash. Only these 4 values will come in my DB. This is a enum. Okay. Similarly, fats is a enum and only 2 values are possible, y or n. Similarly, recyclable y, n. Okay. This is a, so this is what it is given is int, enum, enum. Product ID is the primary key, column with unique values. Low fat is enum with y or n, and recyclable is also enum, which is if it is a recyclable or not. Write a solution to this table which are both recyclable and which have low in fat, right? So what you'll do, you want to return, so input is this, like this. You want to return only the product IDs. So if you want to return every column, you can do select star. If you just want to return product ID, just select product ID from table. Table is products. And now where is will have some condition. So the condition is low fats is equals to y, means it's a low fat product, and recyclable okay. Low fats should be yes. See, yes, first product ID, yes, third product ID. This is output. So let's submit. Okay, now let's come to the second question. We'll quickly solve this. I'll not draw anything. So we have table, we have ID, name, referee. So in here we have ID, here we have name, here we have referee, and int, varchar, int. In SQL, ID is the primary key. Each row of this table indicates ID of a customer, their name, and the ID of the customer who referred them. So basically, let's suppose there is a customer one who have some name XYZ. He is being referred from customer 2. Let's suppose. Find the name of the customer that are not referred by the customer ID 2. Return the result in any order. So here first person Will is not referred by anyone. Second, Jane is not referred by anyone. Third is referred by 2. So we don't have to return Alex. Fourth is not referred by anyone. Fifth is referred by 1. Well and good. Sixth is referred by 2. So we don't have to include Mark. So Alex and Mark should not come. Everyone else should come. Right. So what we have to do, select only name from customer where ref REEID. Either you can do this. Let's check if this will work. Is not equal to referee ID is not equal to 2. Okay, we have to remove them. Referee ID is int. Output, I am only printing Zach 1. Okay, null it's not picking. Good. It's only picking 1. So that's why only Zach is coming. So it should also pick these null values, right? So this is also not equal to, and this is also not equal to, right? So not equal to 2 or referee ID equals to null. Now let's check. There is no case sensitive stuff here. You can use a select and you can use this also, or you can all do in select also like this. Okay. Okay, now also Zach is coming like this. Zef referee ID. oh sorry, is null. Got it? So is null is there. You don't have to like it will not work like this. Okay, is null keyword is there itself. Fine. So we have done two question of select. You can do other things where you will, the best source whenever you want to check anything is W3 SQL. Again, W3 SQL, you don't have to go through each and everything. You don't have to go through, just solve the questions on the go, learn. Okay, basic joins. Now the first, let's suppose, so we have one column employee where everyone have employee ID, everyone have name. So here we have ID, here we have name. That's the one table. Second table is employee university, I think, or unique ID, I don't know. So it has ID, again ID, second table, and as unique ID. So ID is the primary key for this table. Each row of this table contains the ID and the name of the employee in the company. And second table, each row of this table contains the ID and the corresponding unique ID of column in that company. So first table just tells us the employee, if that employee is in the company with some ID 1, 2, 3, 4. And then another table is employee ID, then mapped to some unique ID. Let's suppose you are working in some company, right? You will have some punch-in ID card. So that ID card is different than your normal DB auto increment ID. So what it does is that 1, 2, 3, let's suppose is Rahul, Ram, Sham, and those 1, 2, 3 IDs are here. And okay, let me just try to visualize this. So here it is ID, here it is name. So ID is 1, 2, I think 1, 2, 3 only. They must have given, yeah, 1, 2, let's suppose Alice Bob, right? Another table is ID and unique ID. 1, 2 and unique ID is, let's suppose 90, 50. So these are the IDs for office punch-in attendance, and these are just the normal IDs. So these are two tables, first of all. And then what they are saying is that write a solution to show the unique ID of each user. If user does not have ID, replace just and show null. What they are saying is key, let's suppose these two employees are there. What you have to do, you have to print the all the employees ka unique ID, and you have to print output is unique ID and name. Okay, so you have to print unique ID and name, and if anyone have no unique ID, then print null with name. Print null with name. So what they are saying is, let's suppose there are 3 employees, Alice, Bob, and Ram, and there is no entry of Ram here. So what I will do, this is table 1, this is table 2. Which join I should do? ID is common. We need all the names irrespective of the ID is present or not. So all the name I need. So T1 left join T2. So all the values of T1 will come, right? Left join is, these are 2 tables. All the values of T1 come and common values. So common values are 1, 2, 1, 2. These will come, right? These values will come, and new table will form like this: ID, name, unique ID. Okay, new table after join will be like this. And why ID is appearing only one time? Because my join will be on ID. So table T1 join T2 on ID. So on ID, both the common values will come first: Alice Bob, and unique ID is 90, 50. Now the third will also come, 3 Ram, because I am doing left join, but there is no unique ID, it will become null. And this new table after join, so whenever you join T1, whatever join, left join, outer join, full join, whatever join, T2, whenever you join 2 tables, a T3 will come, intermediate table will come, and whatever you do, select star from T1 join T2 is basically a new table where I can make condition of T1 dot ID is equals to T2 dot ID, and T1 dot age is more than 25, like this, all the conditions. Like, now let's go select unique ID and name from. So the left join will be employee, left join on, either you can use on employee dot id equals to employee uni.id. Let's check this first. Okay, accepted. Now there are more abbreviations that I will tell you, that if there is your table name is employees present in company, too long table name, right? You can write that as employees even. Let's suppose this table you are writing employees even, this is E2, right? Now whenever you want to do employees.id, you can do even.id. Whenever you want to do this, E2.id, right? Let's run this. Okay, accepted. Now this one also, unique id, you want to select unique id. Let's suppose unique id is also present in both the table and id is also present on both the table, but you have took join on id, so the common column will be id here. Because unique id is present in both the table, unique id will come here. Unique id, I'm just taking an example, unique id will come here. And when you are saying that select unique id from this table, so this is the E3 table. Let's suppose whatever you are joining, new table will become like this, E3 table. You are selecting a attribute which is present in both, and you have not taken the join on that common attribute, then that common attribute will come from both the table, that will come, right? Because my join is not on that attribute, so then it will not know how, from where to use unique id. So in that case you can use this even.unique id. So even table is my here, even don't have any unique id, this E2 has, right? E2.unique id, even.name. Let's see if it will run, right? It will run. So this is how your abbreviations are there. Like you can declare any table with a short name, you can use left join, and you can extract the attributes with that table specification also. You got my point, right? Let's suppose this table has let's suppose first table has let's suppose DOB, it is date of birth. Second table has DOB, same name, which is date of boxing. Okay, let's suppose all the employees are employees of a MMA or some boxing company, right? So all the people have some date of birth and date of boxing when they are boxing, like on their like debut of boxing, whatever. But the column name is same. So whenever I will join both the table on ID, this DOB both will appear here. Here also this DOB will appear. DOB, here also this DOB will appear. So when this T3, like T1 join T2 will make T3, and you want to select DOB, it will confuse where to get DOB, right? So that's why this thing is there, giving the table name dot. Okay, now this one more question we'll do on joins. So you have a sales table, which have sale ID, product ID, year, quantity, price. So this is a product ID, sales table of a product, and here sale ID and year is the primary key, right? Multiple sale ID. So the primary key, the unique key is the sale ID and year, not only sale ID. Product ID is a foreign key to product table, right? So foreign key is basically product ID is present here. Let's suppose 1, 2, 3, and those 1, 2, 3 will present here with product name. So two tables are there. So it has product ID first table and no information related to product anywhere in the first table. But in the second table, those product ID have some metadata or extra information, right? Here in the second table, product ID is the primary key. Each row of table indicates the product name. Write a solution to report the product name, year, price for each sale ID in the sales table. So fairly simple, right? So select, you want to get sale ID, column, product ID, year, quantity, price, from. So basically first table have sale ID, product ID, year, quantity, price. Second has product ID, product name. Both of them have common thing, which is product ID, right? That's why product ID is foreign key in first table, right? They have not talked that they want all the products. They have not told us that they want all the products. They just told that we want all the products जिनकी sale हुई है. We want only the name of those products. We can use inner joins, right? We can only extract out the product which have names, right? So from from sales, inner join, product, where या फिर on भी use you can use where also. Let me use where sales dot product id is equals to product dot product id, right? So sales dot product id, product dot product id. Now see, product id field in this list is ambiguous because I am not using on. I'm just inner joining them first. I'm joining them without using any on. So that's why here product id is not used in on. Another table is formed using a normal join. All the values will come, and then I'm putting a where condition, kind of inner join, but whether I am joining them on the time of joining, there is no on condition. That's why this product id will have two columns in my new table, right? So what will happen is I will give sales as S1 column name and products as P1, and use anyone. Sale, let's suppose sale, right? Sale ID is common, sale ID is only once. Only the product ID, because I am not okay. I'll tell you. I'll draw things. Let's use only join and run. Okay, product name, year, price, year, product name, year. Okay, we don't even need product ID, then it's fine. Okay, so the thing is that here you don't have to have I thought that they also need product ID. In that case, I have to use some table dot product ID if the product ID is appearing in two tables. Okay, now the basic aggregation function. So you have aggregation like count. You have aggregation like count, where you want to count the rows. You have average, where you want to average the price. Let's suppose there is a column of price in products. You want to take the average. They have min, they have max, right? They have median, etc, etc. So here we have cinema table, and cinema table has ID, cinema movie, description, rating. ID is the primary key for this table. Each row contains information about the name of the movie, genre, and rating. Rating is 2 decimal places float in the range of 0 to 10. Write a solution report the movie with an odd number ID and description that is not boring. So I'll not waste any time. Select we want to output ID, movie, description, rating from cinema table. Now they have told where rating is odd number rating. So basically, if you will divide a odd number with 2, the remainder will come 1, which is called modulo operator. So they have aggregator modulo, where you can just put the column itself and say is equal to 1 or is not equal to 0. Is not equal to 0 is just meant that if you will take a modulo of any rating column ka value with 2, if it is coming 0, it means even. It's not coming 0, it means odd. Okay, and description is not boring. I think this should work. Expected movie war 8.9, 8.5. Okay, odd number ID. Okay, ID, odd number ID, description is boring, and we also have to return the result in ordered by rating by descending order. Okay, so order by keyword is there, rating and descending order is there. What would happen is whatever the result will come, it will sort out the result using rating column. I'll tell you, just give me a minute. Okay, so whatever the output came, ID, movie, description, rating, I have extracted, right? And all the IDs are odd only, 1 and 5, and rating, these records are ordered by rating ka descending order. So 9 point rating is more than 8.9, so that's why 9.1 will come at top. So in SQL nothing is ordered. Okay, if I will not give this order by rating, what will happen is every time when I will run this query, there is no specific order where the results would return. It is a random order, like sometimes this row can come up, sometimes down, whatever route, right? So yeah, that's one aggregator function modulo. Same here, you want, this is your homework, like this is a prices table, you want to average out the price, right? So average is there, right? So these all aggregator functions are there. Then sorting and grouping, number of unique subjects taught by teacher. Let's solve this. So you have teacher column, teacher ID, subject ID, department ID, and subject plus department is the key. Each row is the table indicate teacher with teacher ID teaches a subject in the department D. So teacher teaches a subject in department this. All are the IDs. Write a solution to calculate the number of the unique students, subjects each teacher teaches in the university. So this first teacher teaches second subject, third subject. So I have to return the count of the subjects, which is 2. For second teacher teaches first subject, second subject, third subject, fourth subject. So 4. So what we can do is select teacher ID and count of the records from teacher table, right? And what I want to do here is from teacher, what should I do? Group by subject, right? And it'll take distinct subject and then group by, right? Okay, teacher ID, count of, I think, distinct subject ID from teacher, group by teacher ID. So this count, after giving the count, I want this column ka name as count. Let's run this and I'll explain you what exactly does it do. Okay, so what happens is, now here 3 things are new: count, distinct, this column CNT, giving a column name. So if I'll not give this a column name, first of all let's discuss that. This will come as count distinct subject ID, whatever I have done. The values will come correct only, but there will not be any column name. So teacher ID, I'm selecting teacher ID. The column name is teacher ID. I'm selecting count this. The name is count distinct subject ID itself. But whenever I type like this, I think as also I can use. Yeah. So whenever I type this as count, means this, whatever the second column will extract out as count, CNT name. From teacher, group by teacher ID. What will happen? See. So you have teacher ID, you have subject ID, and you have department ID. So what you did is teacher 1 1, subject 2 2, teacher 1 3, subject 2 1, department 1 2 3 4, whatever. They want to get all the teacher ID, first teacher ID, and the count of the distinct or unique subjects. So this first teacher teaches 1 2 2 unique subjects, so count should come 2. Second teacher teaches 2 and only 1 subject, so count will become 1. What is happening is I want to first thing I want to do is group by teacher ID. See, group by teacher ID. So what I will do, I will group by teacher ID. So this will make clusters. This will make cluster like this. Teacher ID group by. Obviously group by teacher ID means it will group all the same value teacher ID in one cluster, and this is second. This is what group by does. Now after doing group by, this query will make some aggregation on top of these results. So first iteration will run on this iteration. First iteration is I1 here, then I2 here. If we are not grouping, the iteration will go like this: I1 first row, I2 second. Like this is how SQL will scan. But now we have applied group by. Now it will scan group by group. So what I am doing is, I first of all made group by on teacher ID. Then I made count of distinct in every group. This count of distinct matlab these will be treated as one, right? Distinct. So I will pick 2 columns as 1 column, 2 values as 1 row, and this value is 1. So this count distinct of this SID will give me 2, right? And this is only ID and teacher ID. So teacher ID and count of the first group ka subject ID ka unique count, distinct I have used. If I will not use distinct, see, if I will not use distinct, what will come? 3 and 4. Why? Because first teacher have 2, 2, 3. 3 subjects he is teaching. I'm not talking about unique. I'm only talking about the subjects. So 3 entries are there. So first group is this group. How many subjects are this in first group? 1, 2, 3. 3 is there. So for the second teacher, how many subjects are there? 1, 2, 3, 4. Second group. In second group by teacher ID, how many subject ID are there? 1, 2, 3, 4. So this will come 4. That's why I have to use distinct. So this is what sorting, like we have used order by, we have used group by. Now this is advanced select and joins, and this is subqueries. Okay, and that's all you have to do. Now these questions you have to solve in your homework. Why? Because I want you to go through W3 schools according to your use case. Don't do everything and anything from SQL. It will not be a beneficial thing for you, because in interviews they will not ask you everything. They only ask you joins, select queries, aggregations, and subqueries, right? These 2-3 things are there. You have to prepare. Just solve first 3 questions or every topic, and you will come to know. I want you to solve this. I don't want to make us 8 hours video on SQL and just solving these questions for you, right? So next, let's switch to B+Tree indexing, hashing, our most important topic of all SQL, and then we'll wrap up with acid properties, and that will be our complete DBMS in one go. So now our next topic is indexing and hashing, and we'll go slightly into the depth of this topic, because this is one of the most important topic, both for interviews, placements, and your projects. And going forward, when you'll dig more deeper into databases, this is the one of topmost topic that you have to understand really well. So we'll understand indexing, we'll understand hashing, we'll understand what ordered indexing is, what B+B trees are, how they are used, and how disk IO operations are performed up on top of B+Trees and all, right? And we'll take some examples, some analogies, and all to understand it deeper. So first thing is index. What exactly an index is? So basically, an analogy that I can give you is that you are reading a book, let's say, and it is time consuming, obviously, right? And you don't know where to jump, which topic to read. So there is something called index that you will find at the topmost page of your book, and that index is basically the topmost headlines of your topics segregated into different parts, and those topics are listed in that page with page numbers. So you have some page which have some topics, and you can directly jump in over time, means constant time, right? You know the page number, right? So from just one visit you can understand the whole page directory that is inside the book, and you can directly go to the topic. So that is what an index is exactly in the real world. So index is of two types, right? Basically one is of ordered index, one is of type of ordered index, and other is hash index. So ordered index is basically when you search, so in our in case of book, our search key is our topic and the pointer is towards page number, right? A page number, and this one is topic. So similarly in database world, you have search keys, right? You have search key on like which you will refer to search, and that after finding that search key you will get one pointer which will point to the exact location where you want to go, right? So yeah, that is ordered index. And second thing is hash index. So search keys are hashed and distributed in buckets, so we'll come to that. If you have known the hash function, right? So the basically, let's suppose I have hash function modulo 7. Modulo 7 is basically divide every number by 7 and take its remainder as this answer. So whenever any number will come, its output will be either 0 to 6. Okay, so I have, let's suppose, 7 buckets. So any number who is coming here is modulo taken modulo with my number 7, and this is my function fx is equals to x modulo 7. This is my function. So any number who is coming here as an input will get output, and this output is basically the bucket number. So whenever a new input will come, I just have to run this function, which is again a constant time operation, and it will directly give me the bucket where I could go based on this number. So hashing is like that only, right? So let's suppose you are not pointing this page directly, you are taking hash of this topic. This function could be anything, topic, and it produces some number, and go to that number similarly, right? So yeah, so index evaluation matrices are there. So basically whenever you make an index on top of any database, table, whatever, you have some metrics that you have to care about. The first one is access time, like the time at which you are able to access the index. Insertion time, so you have indexed something and now you want to insert some new records. Let's suppose your book is indexed, now you want to add some more topics. How do you do? And third thing is deletion. Now you want to remove some topic, you're able to remove the topic in very less complex way. And the last thing is space overhead, means whenever you are making an index, so what is the space that is being taken by your index structure, right? So in my book, the space is taken mostly 1 to 3 pages for an index. So yeah, so that's the index evaluation matrix. So these all things are just for your understanding, not important for your interview, right? The important thing starts from here is first one is ordered index. So fundamental principle is indexed entry. So whenever you talk about index, you must have one search key. Let me organize my OBS here. Got it. Okay, so you must have one search key based on which you will go directly to that search key, and you will find that search key. Let's suppose a name of student, you can directly go to the roll number of student, let's say, or pointing to some class, anything. So the fundamental building block of an index is this search key plus pointer. So index can be found using binary search, right? Why? Because if index are ordered, right? So let's say you have index I1, I2, I3 and so on, IN. These are the index, and every index will have internal structure is search key plus pointer, whatever. But if these index are ordered, one of the biggest advantage here is that you can binary search in this list of indices, right? And the binary search you can read on the internet. It's just that if a list is ordered, you can search more effectively in order of log and time instead of constant or linear time, right? So that is something called binary search. No need to worry about it. Just it's a efficient search that is only applicable on ordered sequence, any sequence, right? So the very first pro for ordered index is effective range query. So you have we done some questions. Select star from table, let's suppose, where date is more than, let's suppose, 27 April and less than 10 April. Oh, sorry, 10 May. So whatever, this is a range query, like it has to go to the table of your database, and then it will pick column date, then it will compare the value if that value is like lying in 27 April to 10 May, and it will query in range, it will not query point. So there are two kind of queries, one is range query, one is point query. So whenever you say select everything from table where date is equal to 27 April, this is point query, the exact point where you want to extract the record from. But in case of range query, you don't know the exact point, you just know the boundaries in which all the records can come, and the limit of records can be anything, right? So yeah, if your index is ordered, you have, let's suppose you want to extract all the topics in your book which are not introductory, intermediate, you can just, if they are ordered in order of level, you can just pick intermediate topics, continuous topics, because they are ordered. So very effective range query, able to retrieve a specific order. Obviously if it is ordered, the retrieval order which will you get from the query, it should be ordered, right? So there are two kind of index, right? So first one is primary index, second one is secondary index. Primary index is also called clustering index, and it's both of them are very important. And primary index, just the definition we will cover first is that index is sorted according to the search key, and index also arrange actual storage. Means data records are themselves stored in order with indexed order. Due to this, indices are clustered based on primary search index. I know most of you might not have understood that what does this mean. So basically this means is that whenever you make index, we made some index in book, right? So there is topic, there is page number, and actual pages are also ordered in that number only, in that sequence only in which the index is given. So this is my data store, which is my further book where all of my pages are there, and the first page is index. So they are saying that if index is, let's suppose first topic is database, second topic is introduction to SQL, third topic is NoSQL, and the pages are also according to the index order only, SQL, what are SQL, what is NoSQL and all. So that's what primary index means, which means that the actual data, like the actual location where data is stored, is also managing the same index order which is there represented in the index table itself. So that's what primary index or clustering index is. Now you can cluster here, you can cluster here, right? Let's suppose I can make two pages cluster here. Whenever if someone wants key first two topics, where are they, I can just say that in first set of pages, this first cluster, this is second cluster. So kind of this analogy you can apply. We'll take an example, don't worry, you'll understand. What is primary, what is this, PK versus SK? While primary key oftenly get used as search key, but a combination of attribute or search key. Okay, so there is something called primary key. You must have understood primary key in our previous, when we solved some of the SQL questions, where we read our problem statement, where it was given that customer table is given, where customer ID is the primary key, and also enhanced ER diagram, we also went through this primary key. So they are saying that what is the primary key then? What is the primary key? Let's suppose what I am referring is a search key. We are saying that every index is of structure, search key and pointer. They are saying, is this search key different than primary key? If yes, how? This is the question that can be there in the MCQ format. So they are saying, while primary key oftenly get used as search key, but a combination of attribute can also serve as search key. What does it mean is that let's suppose primary key is customer ID, which is in your table. Like in your table, all the records can be uniquely identified by this key, which is customer ID for your customer table. Now the search key for the same, like this table, must have index. Like how indexing works, there is some table which stores your data. Now on top of that, some index files are arranged which allow user to communicate, to find the records from the table effectively. So those index files are separate, this data in tables are separate. Okay, so the primary key in the tables is different than search key, which is present in the index. Why? The search key can be a combination. Let's suppose customer ID plus date, customer ID plus date of insertion of that record, right? So new records could go in in index file, could go further, like in the future can be appended, I should say. So that's how search key is for index files, primary key is for your table to uniquely identify your records at DB level. Okay, so second index is secondary index, which is also known clustering index. A secondary index search key doesn't determine the physical ordering of the data file. So what is it saying is that let's suppose your index file is there, you have arranged all the index based on which you can go to a specific location. Now they are saying that these locations are not ordered according to the index file. So basically, let's suppose first index, 2 and 3rd, 4th, and this page is P1, P2, P3, P4. Now the actual location where these pages are stored, maybe P2 is coming first, then P3, then P1, like this, right? The actual order of the actual pages where it is stored, that location is not determined according to the index file or index order, because data is not clustered. Now you will not be able to cluster the data, because see, first two pointers are here, but you don't even know that if the first page is closely packed with second page or not, right? So data is not clustered according to the index order, hence retrieving data might require more IO. What does it mean is that, because see, in database terms, where you have index files, which are stored in your hard disk. These files tell you how to directly go to a location or a set of location to get the data, and that data is stored in your disk. And whenever you read from the disk, there is some input output operation which blocks everything, like CPU and every resource, right? So this is your hard disk. This file is also on hard disk, but this hard disk have some blocks, some pages. So now to extract these pages, I have some pointers. So what it is saying that when these pages are not closely packed and the order is not determined, then you can't, it's not clustered, it's not closely packed, you can't get the data out like in very effective way. It will take more IO. So why to use clustering index, non-clustering index, which is secondary index? We'll come to that, don't worry. This index is not meant for the main index, it is kind of intermediate index, we'll discuss. So index sequential files. What are index sequential files? Are they different from the actual data location where data is stored, right? So this is a very common question. What are index sequential files? Because these are the main starting point for any query whenever you run on a table. So yeah, the data records are stored sequentially in order of primary index. Search key. So what it is saying is that the data records are stored sequentially in the order of primary index search key that we already covered in our clustering index. It provides a starting point to sequentially access. So but what they are saying is that whenever you have index file, you have a pointer, it tells you the starting point for that data. Let's suppose I wanted to extract the data from date 10 April to 10 May, and it will give me the starting point to which page I have to go into disk and then fetch the records, right? So this is called sequential index sequential files. These are files which are ordered according to the data, or data is ordered according to the index, vice versa, right? And first example is employee DB. Let's suppose you have employee database which is ordered by the employee ID in the table. Let's say employee database is storing employees in ascending order of their employee ID. Okay, now the primary index would be on employee ID with employee ID as a search key and pointing to the disk location. What it is saying is that if you have a file and if you have a table, your table is sorted according to the employee ID. Now this table, this can't be stored in complete one chunk of memory. So basically this first is pointing here, second is pointing here, third index pointing here. Let's suppose I know the starting point for this employee ID 1 to 5. The starting point is this. I have to start from here. Now I can extract the data accordingly. Right? Because I know the starting point in my disk. So now to retrieve employees, one range query would just work fine, right? Employee DB, index on employee department. Now let's say same DB is still ordered according to the employee ID and we want to frequently access employee department. Now your index sequential file and your table both are sorted according to your employee ID. But what you want is that you want to frequently access employee department. So a secondary index would be created on the department field. Why? See, the records which are frequently accessed, it's better to have an index on those records, because index make the search, the lookup very fast, right? So when my use case was on employee ID, that I want, so I started making a service, let's say, and I know that in future I will my first requirement is to extract all the employee according to their ID, and I made an index on top of my employee table, employee ID, right? Now going into the future, nobody knows the requirements, and one new requirement comes up, that now your read throughput, your read queries will be more on employee department than your employee ID. So what you'll do now, you have to make sure that your employee department access is also efficient than employee ID. So you now, in this case, you can create a secondary index. Why? Because your table was already sorted, like the data location is already sorted according to employee ID, but you can use secondary index which doesn't need any sorting. So index would have department and list of employee ID as a secondary index. Since the data is not physically ordered by the department, hence we have to use department and then get employee ID and search in them. What are they saying is that you have a search index, a secondary index file, you have a secondary index file, you have a normal primary index file. From this secondary index file, you will know, like from the department, you will know which department is starting from where, which location, and then use your employee ID ka, starting point. Don't worry, you'll understand with the examples. So first thing is dense indexed files. This is very important. Dense and sparse indexed files are very important. So first one is indexed file, dense files. So index record appears for every search key value in the file. So what is it saying is that, let's suppose my name is here, and I make a index based on my name, and every name has a, this is my search key name, and this is my pointers to the location. So dense index is every record has one index. What is the benefit? There is one benefit, which is space space optimization. I can cache this stuff, right? While caching this huge table is hard, caching just a name column is more easy, and pointer is anyways very small as compared to the actual data. So yeah, dense indexed files good for, I think, most of the use cases where RDB doesn't scale exponentially. So the second thing is sparse index file. Index records for some search key values. So there is Rahul. We have the starting point for Rahul. We don't know about Manas, right? We have Mohan. We have starting point for Mohan. We don't know Rohan, Rogu, Vinayak. We have Vipul ka pointer. We don't know Chand and Kal. And all these records are connected, self-connected to next record. Okay, so this saves more space, less complexity while deleting, right? Less complexity while deleting. Why? Because see here, if I am deleting any record, I have to remove with every deletion of record, I have to remove a single record from my index files. And if this index file is cached in RAM, then I have to also flush the cache and then again refresh. So yeah, so slower than dense index when retrieving the information. So you'll say, why to create this thing? See, if you have done any algorithm, you will know that most of the time we have 80-20 rule. Like you have, let's suppose, 100% of the data, and 80% of their data is not accessed more frequently. Only 20% are high influent users whose data is more important and accessed more, right? Let's suppose in terms of e-commerce, the people who are merchant, who are bulk ordering, their data is more they will read more data instead of a customer like me who will order once in a month, right? So that's how sparse indexed files are important. So yeah, the second thing is multi-level indexing. So in every computer science topic, we did virtual memory, right? In virtual memory, you have virtual memory address space, which can expand more than your physical memory from 2 GB to, let's say, virtual memory can go more than 2 GB. Now your virtual memory has to map every memory location to a page, page number to page frame. Like this is virtual memory to actual memory mapping. Now this virtual memory can also be divided again, multiple stages can there. Like similarly, neural networks, you have one layer, you can add more layers, multi-neural network, right? So one layer I think is perceptron. So that's the To increase the complexity, you will get to know that every topic has, you know, subdomains. So that's how, like, the main thing is index. Now the subdomains are like stack them over each other and make multi-level indexing. So the primary index doesn't fit in memory, then they can kept in disk. So if you have a primary index, which is a clustering index, right, which is a huge in size, if it is not able to fit in RAM, now you have to keep that primary index into your hard disk or disk, right? RAM is fast in terms of access. But anyways, if your DB is large, you can't do anything. Then your primary index doesn't fit in memory, then they can't kept in RAM. They have to keep in disk as a sequential file, and we can construct a sparse index on top of it. Sparse index on top of it, outer index, a sparse index of primary index, inner index, the primary index itself. Outer index is also large, another index can be created. Every level index has to be updated on insertion and deletion from the file. See, this is data block, like the actual data which is stored on the disk. This is data block 1, this is data block 2. So inner index, every inner index has, now this can be primary index, secondary index, doesn't matter. This is just an index which indexes some records to the data location. Now this inner index is itself in huge, right? So I can't store this, I can't cache this in RAM. So this also will go to disk, this also will go to disk. Now outer index, I'll take more, abstracted index. I'll take one arrow per table. So this could be a secondary index, this could be a secondary index, like let's say it alternate rows has in mapping, right? But this has only one mapping per table. So let's suppose you have 20 records here, 20 records here. Let's suppose every alternate, it will have 10 pointers. It will have 10 pointers or 10 records here. Now here only 2 records will be here because 2 tables are there. So see, this can be cached. Obviously I agree that the retrieval will become little slow, but there is a trade-off, right? There is a trade-off. First trade-off is you have cached things in your RAM, and your access time will increase for the first retrieval of your starting point. But if you keep everything in RAM, now your compute has to increase. So there is kind of trade-off, right? Yeah, so this is one of the examples, secondary index on balance field of account. So basically you have account, right? There Rohan has a debit account, and the card number is 2026 and date of opening, let's suppose. And these 350, let's suppose, is his last 3 digits of card number, and this 350 is here, and it will go here. And this is also might be a table or just a pointer, direct pointer, right? Secondary index has to be dense. Secondary index has to be dense. Why? So dense means, let's go here. Dense means every record has pointer. So if you have secondary index, let's suppose this is the inner index, this is the outer index, and outer index I am making it as a secondary index. This has to be indexed because so see, my first starting point is this table which is cached. So I want every record to be mapped to something, so that I don't find any record which is not mapped and I would be stuck there, right? So that's why every record must have one pointer, so that I would find a path to go to my disk, right? So sequential scan using secondary index is less efficient, as I already explained. It is less efficient. We can't do anything. Okay, now we discussed about indexing, like indexing, the ways of indexing. You can index using primary index, using secondary index. You can stack multiple indexing here and there. But these index, we have just discussed that these index are just search key plus pointer, and we have just represented these index, whatever, like primary index, secondary index, inner, outer, whatever, these as table. But do you really think that these are the tables which are there in our computer or our system? Not really, right? So B+Trees are the data structures which actually implements the index files. So B+Trees, first of all, we'll discuss about their index files. Okay, so B+Trees are nothing but index sequential file alternative. So index sequential files, whichever we have discussed till now, the tables, kind of these. So these will increase with size, right? So performance degrades as file grows. But how B+Trees tackle them? So B+Trees have some conditions. So people who are aware about binary trees, or I should say binary search tree. So they know that they have some rules which make those binary trees as, you know, kind of log n ka tree. So you have root. So all the left children ka value should be less than root. All the right children ka value should be more than root. So applying these rules make sure that our binary search tree in an average case will become balanced. I mean, the maximum depth will go to log n. N is the number of elements in the tree. You know, this is not the worst case. I am talking about best case, right? Worst case is basically it will go linearly and will kind of form a linked list. But yeah, so forcing these rules make sure that your data structure have some insertion ka deterministic order, updation ka deterministic order, update karne ka deterministic order, and your depth of the tree is also within the limits. So there are some rules that have to be enforced so that our B+tree doesn't grow exponentially or linearly. Linear only is possible, I think. So in B+tree, all the paths from root to leaves are of fixed length. Every leaf, pick every leaf. Okay, the path from root to the leaf will always be fixed, like as compared to others. Each node which is not root. So basically you have B+tree. First rule is we are talking about non-root nodes. Each node which is not root and leaf has between n divided by 2, whatever n is the number of elements in the B+tree ka ceiling. Ceiling is basically 3 divided by 2 kitna hota hai? 1.5. The ceiling of 1.5 is 2. Like the ceiling is terrace and floor is, your floor. So, and children. So every node which is not a root and which is also not a leaf, just an intermediate node, has between n by 2 ka ceiling and n children. Itne children rehne chahiye. If it exceeds, you have to modify the tree. Leaf node. Which are the leaf nodes here? Leaf nodes has n minus 1 divided by 2 ka ceiling and n minus 1 values. We'll take an example. Special case, if root is non-leaf. If root is non-leaf, it has at least 2 children. If root is non-leaf, means root has some children. It is not leaf. If only root is there, it's also a leaf, it's also a root. We are talking about if root is not a leaf here in this case. Then it has at least 2 children. It should have at least 2 children. And if root is a leaf, then it can have 0 to n minus 1 values. N is basically the degree. So I know most of you might have not understood this thing, right? So we'll discuss. So basically the structure, any B+tree ka level will have pointers, will have search keys. P1, K1, P2, K2, and similarly Pn-1, Kn-1, Pn. Ki are the search key values and Pi are the pointer to the children. And these search keys are ordered. This order could be in lexicographical, could be in number order, decimal order, like 1, 2, 3, 4, 5, anything. It depends. If your keys are numbers, if your keys are strings, the order could be deterministic. Now leaf nodes. What about leaf node? This is the intermediate node of B+tree, where every node will have pointer, key, pointer, key, pointer, key. Right? All the keys are sorted according to some order. This is the first thing. Second thing is every leaf node, the level of leaf node will have this. So this is the search key. The pointer will directly points to, now this is the leaf. There is no more level of the tree which is available. So you have to go to the disk and your disk is pointing here. So basically whatever we were pointing with files earlier is pointed out by the leaf node of B+tree. So for non-leaf nodes, this is again the rule which we have already stated, that all search key to which P1 points are less than K1. So basically K1 is the key. So it's like binary search tree. All the nodes which are here pointed by K1 are P1 are less than K1. So basically if K1 is, let's suppose 100 and order is according to the numbers, then these search key and these values should be let's suppose 90, 92, 93. And if this key is, let's suppose 200, then this pointer should point to a node which has values between 100, K1 to K2, 100 to 200. So I can safely say that if Pi is the pointer, then Pi should point to a node which have values more than Ki minus 1 and less than Ki. You can just understand from here. Okay, for I more than 2 and less than n minus 1, all the search key in the subtree to which pi points, same thing is written here, right? All search key in the subtree to which pm points are greater than or equal to km minus 1. So basically it's talking about the last thing here. So pn is pointing to some nodes. All nodes should be having value more than kn minus 1. Okay, so this is the kind of ordering structure which make sure that your order of all the values at every level of the tree is maintained. So example of B+Tree is here. Let's suppose we have JKL here. JKL is the search key, and this is the first pointer, this is the second pointer. So first pointer should have pointed to the values which are less than JKL. So I am talking about the string ka order sorting order. String has some sorting order like ABC is less than DEF, right? So ABC, DEF, GHI all appearing before JKL, and after JKL it has values more than equal to JKL. JKL, MNO, PQR. Let's go graphicals, I think. So leaf nodes must have between 2 to 4 values. So first of all, n is equal to 5. Why? Because the values are 1, 2, 3, 4, 5. Okay, and 6. I think this is 6, not 5. Okay, I think this PQR should not be here. It's a mistake. Okay, so this tree is actually 5. Obviously, the 6th value can also come, but yeah. So leaf nodes must have all the rules we have noted above, which is leaf nodes should have this n minus 1 divided by 2 ka ceiling, which is n is equal to 5 here. So 5 minus 1 divided by 2 ka ceiling. 5 minus 1 divided by 2 is 2. 2 ka ceiling is 2. So 2 to n minus 1, which is 4. N is 5. To 2 to 4. Leaf node must have between 2 to 4 values. So it has 3 values. Now the fourth value will come, it can accommodate, and the fifth value will come, the fifth value go here. So how it happens is, let's say here I try to design a B+Tree. So first value ABC, DEF, second value ABC, DEF, GHI, JKL. This is the leaf node. First node I'm inserting the keys. I've inserted ABC, I've inserted DEF, I've inserted GHI, JKL. Now again one more, I want to insert MNO. I'll insert MNO. Now the leaf node will have 1, 2, 3, 4, 5 children. Now this is not allowed. So I will take MNO here, JKL common, and here also I have to make sure JKL so that I can point out. So it will be ABC, DEF, GHI, JKL, MNO, and this is the kind of I'll show you the B+Tree ka visualization also. B+Tree visualization. Let's say this. I don't know. There is a kind of range and all. So I'll add random insertion. So first insertion, second, third, fourth. So for the fifth, it is divided, right? Let's go back. Oh, okay, I can't go back. So add 1. 4 insertions are there. So 5 to 8. One more key I have to insert. Let's say let's see what happens to 5 to 8. It should get promoted. No. Where is it? Add random. Okay, 5 to 8. Now dekho 5 to 8 is here. It's a kind of promotion, right? 533 is promoted. So because of these rules, you have to make sure that your B+Tree is accommodating the elements which you have decided according to rules. So non-leaf nodes other than root, non-leaf nodes must have 3 to 5 children. This also we have discussed, right? Root must have at least 2 children. So you can experiment online that B+Tree, how they are constructed. There are insertions, deletion, updation in B+Trees, how they get inserted, deleted, updated, but they are not important. Only thing which is important is how B+Tree nodes are primary key, search key, index, and pointer, and what are the rules. n-1 divided by 2 ka ceiling to n-1, and all those rules are important. Apart from that, nothing. And the leaf nodes point to actual data disk ka location, right? Okay, यहाँ तक समझ आ गया. Good. Now let's go to B+Tree file organization. So index file degradation problem is solved by B+Tree. Leaf nodes, B+Tree file organization store records, actual records instead of pointers. You will already saw that. Records take more space than pointers, you know. Now the B+Tree came from B-tree concept. B+Tree came from B-tree concept, but B-tree is not used. B+Trees are more effective and efficient. Why? We will discuss about B-tree also, because some of the MCQ question could come around B-tree versus B+Tree. So the only major difference is in B+Tree, the search keys might get repeated, as you have already saw that here JKL is present here also, so that you can, you know, point. But in B-tree, one search key appears only once. It is similar to B+Tree, but it doesn't repeat search key. Generalized B-tree is like this only, B+Tree only. Non-leaf node BI are the pointers to the bucket or file, like that only. Okay. Disadvantages. Main thing is this thing. Disadvantage: only small fraction of all search key are found early. Okay. Implementation insertion is complex. So this is to there. B+Tree ka insertion completion is different, complex. B-trees generally have greater depth than B+, because, you know, there are no kind of strict rules, and also your search key is also, you know, appearing only once. So it's a kind of, you know, search is kind of fuzzy. You can search B-tree plus B versus B+Tree, but the thing is B-trees ka you should know, so that you can solve the B-tree questions also. Now the second thing comes, it is hashing. Now the people ask about hashing. It's not widely used, but it's really important concept, because there is something which is, you know, solved by hashing also, and it's not too complex. So let's suppose we have 4 buckets. Instead of storing all the data in one chunk, we are storing in different buckets in our disk. So bucket 0 have some data, like we always represent data using tables because it's really easy to understand. So bucket 2 has Rahul, some other columns, and Mohan, Sur, some other columns, right? We have 4 buckets, 0, 1, 2, 3 are the index. If bucket overflows, now we have 4 buckets with 3 rows. We are storing data in bucket 0, bucket 2, 1, 2, 3. Let's suppose our hashing function, whenever any new record comes that we need to store in our disk, we do this. We apply a function, and this function gives the value between 0 to 3. This function could be modulo with 4, whatever, but it will always give the function 0 to 3. And this function could apply on the person name, the person roll number, whatever. Okay, the function is on us, but the output, it will get produced to 0 to 3. Now it produces outputs, this produced this. Now this bucket is full. Now what will happen if bucket overflows? Then closed hashing is used. This is really important concept in DB. What is closed hashing? Which means overflow bucket form a chain in terms of linked list. What will happen? Let's suppose I added Rahul. Let's suppose I added Mehul, and I added Sohal. Now one more guy came, Rohil. Okay, now this Rohil can't be inserted like this because my bucket will overflow. What I have to do, I have to make a linked list, a pointer to a record, Rohil, like this. Okay, and now like this a linked list can form. So that is called closed hashing. Hash indexing. What is hash indexing? So see, we discussed about index sequential files, where the files are stored in the index form, right? And we then discussed about B+Tree. It's a kind of way to manage the index. Now here comes the hash indexing. What does hash indexing mean is that now you can see here we have bucket 0, bucket 1, bucket 2, 3, 4, 5, 6. We have 7 buckets, 0 to 6. Okay, and this bucket overflowed, hence we have one more bucket which is pointed by this bucket. Now this bucket will overflow, one more bucket. So this is how a linked list will form, and this is called closed hashing. Now these buckets can be indexed to the actual data. This is the hash indexing, as simple as that. The question will come around indexing versus hashing. Okay, so the cons of static indexing. Why is this static indexing? Because my function is fixed. My function, which always gives value between 0 to 6, this is fixed. Whenever my database will grow, these buckets will overgrow, and most of the buckets will form linked list, most of the bucket, and my DB over the time will suffer. So this is static hashing, where your function of your hash function is fixed. Where you give input, it will give you a bucket. Now the data grows with time, and the number of buckets is small earlier. Too much overflow will degrade performance. And if you know the data growth, You allocate number of buckets high, then initially when your service is new, when your data is not there, then you will waste your space. What is dynamic hashing? This is the most important thing in hashing, dynamic hashing. This is good for DB that grows and shrinks in size. With time you are deleting record, with time you are adding things. So this is good for that, where DBs are growing and shrinking. Hash functions can be modified dynamically. This is most important. This also got extendable hashing. What it does is that it has some number I. Let's suppose I is equals to of 1 bit. 1 bit is either it can generate bucket 0 or it can generate bucket 1. It always uses prefix. Take in mind that it will always use prefix. Will come that point. So I want to insert some inputs. Let's suppose input is student ka ID, student ka roll number, student ka name, and in hash function is on student ID, and it will always give me the values between 0 to 1. Now this function could be anything. This function could be, I'm just assuming, okay, mx plus y, whatever, okay, I don't care, but the output should be 0 or 1. So I have stored one record here, one record here, one record here. Now one more record comes whose value is generated as 0 from the hash function. What it will do? It will break this bucket. It will break this bucket and it will increase the value of I to 2. Now this 0 will become 0, 0, 0, 1. The prefix is still 0. The prefix is still 0. So now the value, if value is generated as 0, value is generated as 1, 0, 1 or 1, right? Now let's suppose for this bucket also it gets full. What will happen? This bucket will get divided into, the prefix will remain like this, 1, 1, and now 0, 1. So this bucket will be divided in 2 buckets. This bucket will divide in 2 buckets, right? So now this bucket is 1, 0. So let's suppose this bucket also gets full. So again a new bucket will get formed, which is 1, 0 will remain there. Here 0, 1. Like this. Prefix will be used. Prefix will be used. Right? 0, 0 or here 1, 1. So that's how you are breaking out the buckets. So now from this state I have came to this state, I have 3 buckets. Now for this state I will go to this state, will have 4 buckets, right? So that's what dynamic hashing is, where you increase the value of I is actual the number of bits. So again, this is important. Indexing versus hashing, ordered indexing specifically. When to prefer what while deciding. So indexing is basically B+Trees. Whenever we talk about indexing, it's mainly B+Trees. And indexing, as we already discussed, that it's preferred for range queries. It's preferred for retrieving ordered data. It is designed to minimum the disk of IO input output operation, slightly lower because you have multi-level indexing. Hashing, it is suited for unordered data because your buckets, there is no specific order and it's highly dependent on the hash function. It is suited for no range query because the hash function will always tell you the point instead of the starting point. It always, fx will always give you the deterministic value instead of the set of values. For large DB, go with indexing for optimize for large DB. See, for large DB, if you will go with hashing, it will keep on increasing buckets. For in-memory small DB, you can go with hashing, but hashing will still give you unordered and fast data. High modification can give index maintainability overhead. So basically, whenever you are making high modifications in your data, so your index files ka B+Trees have to readjust themselves to make sure that they are balanced and remain under the limit. So yeah, in general, indexing is always preferred to get a balanced result because it gives all the results in a balanced way, like the speed, lookup, range, and ordered queries. Now the next thing, this is most important thing that always comes whenever you are giving an interview, which is ACID properties in DBMS. ACID, A for atomicity, C for consistency, I for isolation, D for durability. What does atomicity means is that whenever you make any query in database, it is called transaction, right? It's not like the bank transaction, but its name is just, notation is transaction. Okay, so what is transaction means is that, let's suppose I want to add a student in my DB. So I query my DB, I read something, and then I write student. That is a transaction. I made some transaction to my DB. I made some transaction, which is that made some change in my DB. Now let's suppose it's a very classical example of transferring 200 rupees Okay, 100 rupees from X to 100 rupees to Y account. So X has 500 rupees before transfer, Y has 200. Now I want to carry out this T1 transaction, which is to transfer here. So I will read the account value of X, which is 500. Okay, I will subtract the 100 rupees from here, okay, which will come 100. Then I will write those 100 rupees into here, and then my X will become 500 minus 100, which is 400. Now in the Y, what will I do? I will read Y. I'll add those 100 rupees here. I'll write those 100 rupees into DB, which is 200 plus 100, 300. It will become 300. Here it should be 400, not 500. Okay. So this is transaction. See, you are doing some modification in DB. This is transaction, and this is carried out by transactional log, which is write ahead log. This is again out of interview boundaries. Nobody will ask you what is write ahead log, but I am just telling you that most of the DBs use write ahead log, not log, it's log. Write ahead log, it's log, to record all the changes before it is made in the DB. So basically, before you are changing anything into your DB table, you are writing those records in a copy. So it's kind of making your timetable before you are doing your actual task. So what does that help us with is that let's suppose you are transferring 100 rupees from X account to Y account, and your database crashed, but that log would be there in your write ahead log, and because of that log, you'll know in future that I can use that log to again resume my transaction, right? So before doing anything onto the DB, it writes something in a file, log file, which is write ahead log. Then it makes sure that it carries out the transaction, which makes sure that your database is atomic. Your transaction will either complete or it will either fail. Whatever your transaction doing, it will either complete or it will either fail. It will not go in an intermediate stage where X has deducted 100 rupees and Y doesn't got any 100 rupees. It will not be in a inconsistent state. Second thing is consistency. It makes sure that transaction will take DB from one consistent state to another state, consistent state. What does it mean is that let's suppose you have one table, you made some transaction and you got the another state of the table, not a new table, but the new state of the table. But so whatever the transaction you have taken, okay, that will make sure that your DB is in consistent. So it's one consistent state to second consistent state. It is not an intermediate state. It will be a robust, successful, after successful transaction जो होना चाहिए वो वाला state. Okay, that's what called consistency. Isolation. Let's suppose you are carrying out, you have one DB, you have multiple users to your app, right? Your app make modification on DB. Your app concurrently takes over so many transactions at a time. So all the transactions are unaware if those other transactions are happening. So that's what this isolation property of DB ensure that concurrent transactions which are happening on the DB are independent and results are same. Let's suppose even transaction T1 came first and then T2. It doesn't matter if T2 comes first and T1 came later because they all are independent. That's what isolation means. Durability. It ensures that once data is changed, let's suppose I am changing my data in my table and I have deleted some student, it will get persisted and will remain even the system failure. Now the system failure, see, there could be a doubt that say what if hard disk even crash itself, right? Where database is stored, then you are gone now. Okay, but nowadays you use EC2 machine, which is Amazon ka EC2 with EBS, elastic block storage, which is distributed itself. So don't care about that. You just have to care, like if EC2 goes down, your computer goes down, your disk will always get persisted data. Why? Because it ensures once data is changed, it will get persisted and will remain even the system failure. Updates will get permanent stored in non-valued. First of all, we have write ahead log. Before I'm even changing anything into the DB, you make a log into the file, then you change. Let's suppose while changing your DB crashes, you have the log, it will use that log to resume the change. So durability, right? Now the most important question, RDMS, relation DBMS versus NoSQL plus what is sharding. So RDBMS, which is relational database management system, stores data in such a way that relation could be formed and strong emphasis on ACID properties. Relational database हमेशा ACID properties के ऊपर बहुत ज़्यादा ध्यान देते हैं. NoSQL stores whole record in one object, document or graph like this. एक student है, उसका नाम है, उसका एजुकेशन है, इट हैज़ आईडी और उसका डिग्री, इट हैज़ आईडी, डिग्री, एवरीथिंग इज स्टोर्ड इन द वन ऑब्जेक्ट. right? NoSQL records can be distributed across different nodes. Why? Because let's suppose I have one computer here, node 1 distributed, node 2 is distributed somewhere else. Now I can have some data here, I can have some data here. Why? In case of NoSQL, if for student 1 I want to get data, I'll get all the data from node 1 only or node 2. I don't have to join anything. But in case of SQL, if I do this, I might have to join some data from here to here, because all of the data for student 1 is not necessarily present in one table. There could be multiple tables, and it is a possibility that I have made one table in one node, another table in another node. Now a high network lag will come. I will retrieve node from data 1 from node 1, data 2 from node 2. I will make inner join, and then I will form the data of student 1, because relational database have the data in relational manner. They are scattered in tables. So that's why NoSQL can be distributed and distributed across the nodes, which is also called sharding or horizontal scaling. That's why NoSQL databases are horizontal scalable. There is a trade-off of consistency. NoSQL databases doesn't guarantee consistency, they guarantees eventual consistency. So there are two type of consistency. It's not important, but if you are making projects, it's really important. First one is consistency, second one is eventual consistency. Consistency is that we have discussed that you have made any transaction in your table, it will take your table from one consistent state to another consistent state. No query can come and read any inconsistent intermediate state in SQL. But in terms of in relational database, in terms of NoSQL, you have eventual consistency. Why eventual consistency? Let's suppose you have node 1, you have node 2, you have student 1, you have student, let's suppose 2. Like the data is scattered. Now whenever you want to insert anything or retrieve anything or modify anything, this state might want to sync with this. Obviously this node has to sync with another node. While this network activity is going on, some person can come and read the stale data. Stale means old data. Let's suppose student 1 is removed. Student 1 is a brother of student 2, right? When student 1 is removed from the school, student 2 has to be removed. Although both are different, they are not related, right? As in strongly related, but I have to just remove student 1, student 2, just because after removal student 1, I have to remove student 2, and it's not a transaction. This is one of the possible example that I am thinking of. And due to network, because these nodes are different, scattered, distributed because of the sharding. So that's what eventual consistency means. After some time, you'll get the consistent data, but intermediate stage could be inconsistent, which is not the case in RDBMS. When data is distributed on different nodes, when a transaction team might need a data from more than one node, and in meantime data could be inconsistent, but after transaction T completion, data would be consistent. That's what eventual consistency. NoSQL gives eventual consistency, not consistency. The question comes, then we can store all the data in one column of RDBMS and we can scale? If NoSQL is storing all the data of one record in one object instead of scattering the data of student, department, teacher in different tables. If we do store all the data in one table, would it make sense to horizontal scale? Yes. And is it a good design pattern? Think about normalization and come up with the answer. Now the next point is NoSQL doesn't have fixed schema while SQL has structured fixed schema. That is one of the difference. Another question comes, horizontal partition versus vertical partition. Horizontal partition is basically sharding that you can do on databases. Vertical partition is basically vertical partition. You have to read about this. This is also important. Not asked too frequently in the interviews, but it's kind of important. Now there is note. Just few of the people might get confused that there are some databases who are distributed SQL and coming in the market who are close to ACID. They are not, like I've already told you that if it is not RDBMS, if it is NoSQL, it will not give you the complete ACID properties compliant thing. It will give you eventual consistency, not complete consistency. But there are some distributed SQL like which are horizontal scalable and still very close to ACID properties, which are CockroachDB and YugaByteDB. You can read more about that. There are some examples of SQL, NoSQL. Now there is a very famous master replica architecture that is used across the many startups in India. So master replica thing is to basically segregation of different use cases. So let's suppose you have one service which writes very little which writes very little, reads very high. Reads are very high, or other way around, writes are very high, reads are very low. So the thing is key, you can divide these DB. Let's suppose you have DB of student, same DB, copy paste another table, another DB, another computer, everything same, everything is same, just on different machines. No sharding, no partition, just copy paste. This is what called master replica. What does it mean is that, let's suppose I have bank app, and I have a bank app here also. Here I am making a payment. Here I am retrieving my profile, my bank balance, etc. Although people make bank payments very less frequently, like the writes are very low, but they open their bank apps very frequently, the reads are very high. So writes are very low, but I want this writes instantly and consistently because these are related to payments. So I will do everything on master, then I will replicate, copy paste these things on my another instance replica, so that my balance, my profile, whatever credit score, everything reflects. And because see, I made one payment, it will make some changes in my DB. These changes I have to copy paste to the another DB, which is again the copy of that. There could be some lag. That lag is affordable. Why? Because human can't open, or human can't come back on the page of, they can't read their balance and profile under some milliseconds. So lag will always be under 500 ms in the worst case, it should be. So even if replication lag is there, you don't need very flash speed real-time consistency in reads. That's why this lag is acceptable, and writes are happening on the main database, and these all main database ka changes are going to replica, and these changes take some time over the network, and this is called replication lag. And replication is carried out using bin logs. You can read more about bin logs. It's a very good thing and kind of advanced thing also. It's not asked in interviews. Master replica could be asked, but this bin logs is not asked. Replication is of two type: async replication, sync replication. Async replication is basically when you get eventual consistency. What does async replication is? Let's suppose your application is there. Here you make a payment. Your code of making a payment is here. You write into the DB, and you will get a response instantly after the write operation. This is async, where you will make a change in DB. This DB will raise an event of bin logs. It will change in bin logs, and it will get replicated to another instance, and those are carried in the background. It doesn't care if this replication is done or not. If the write is done in the DB, it will directly return the response, and my code is instant. That is what async replication is. Okay, in async replication you will get eventual consistency. Why? Because this will take some lag to reflect, and that because of that lag, intermediately in 500 ms of that lag, you will get inconsistent or stale data, like the old data. That's why eventual consistency. But if replication is sync, which means you made a payment, you will wait till that payment is reflected in the master and replicated to replica, and then your further code will run. The overhead is your application will become a little slow in that case, and their strong consistency will come. Okay, so I hope you enjoyed the course. Okay, and we covered more than enough, and actually more than required for interviews in our DBMS in one shot. And you guys should show some love. Okay, share on Twitter, share on social media that what topics you have enjoyed, and we'll soon start making some of the projects on DBMS. Right now I am busy with some or more commitments, but will come on DBMS for sure. But meanwhile, enjoy. Make sure you subscribe or share with your friends. See you soon in next announcement video, and tab tak liye bye bye.